In this video I'm going to look at a BK Precision 820 capacitor meter. It's a battery powered unit powered with 6 volts. Uses 4 C-cell batteries. The range of capacitance you can measure is from 0.1 picofarad to 1 farad of capacitance. I thought that was a pretty unique range because my multimeter that I currently have only goes up to, I don't know, I think it goes up to a farad, but this multimeter's lowest range is 2 nanofarads. While this one over here, its lowest range is 1 nanofarad with a 0.1 picofarad resolution on that range. And the multimeter only goes up to 200 microfarads. Ooh. Oh, it looks like one of those vintage radios. Almost got like the same design. Yeah, it almost looks like a little radio you'd find, a little transistor radio or something. Okay, here's all the range switches on there. Feels like the dial is still intact. It's not really click action, but yeah, I think it'll work. So it looks like it's got four digits in the display. It's kind of like a little front panel here. Banana jack for plus and minus, and then the terminals just to plug the capacitor right in there. It's got a 1 amp fuse in there. Yeah, it's a little touchy. I think I'll look at that later, but I'm sure it's got one in there. And on the back, it's got a little thing to prop it up on the bench, which is kind of nice. And it's got the conversion chart in the back. It's pretty nice also. It's got all the different things how to use it on the back. It's really nice when you look up the manual, which is sometimes hard to find. 1978 on there. Pretty good. On the side panel, it's just like it's like a 2-shell design with 1 shell on this side, another shell on that side. And here's a charging port on it. It's uses a 6-volt charger. So while it stands on the bench, hey, that's pretty nice. Oh, perfect. It's got a very sturdy feel to it on the bench. Apparently this doesn't work, so we have to debug it. Okay, so I'm just going to take off this back cover on here. Looks like it's one of these flat heads where you can use a regular penny and just open it up like that, so you don't need any tools. Everyone's got a penny in their pocket, right? Yeah, I need a little bit more. Oh, it's a captive screw on there. That's pretty nice. There's the odd bolt on there. And they got the 4 C-cell batteries that you're supposed to put in it. I think I'm gonna mod this because I'm not gonna have 4 C-cell batteries laying around. So I'm just gonna use one of the LM317s to generate the 6 volts needed. I guess it's 4 to 6 volts, so I might just use a 7805 for the regulator. Found one. There. Looks like it's a single side construction, and I think it's all through hole because it's a pretty old unit. So they didn't do surface mount back in the 70s, right? Maybe only on the NASA probably did some surface mount back in the day. Oh, looks like I need to take out this knob. Something's catching. Oh, maybe that's why there's this here, because I need to desolder this connection. There we go. Oh. Oh, there it is, right there. Ripped it right, the pad right off. Oops. That's not good. I think it was not. Oh, it was folded over. That's why they folded the metal right over. Yep. That's too bad. But I think it's easily repairable. Looks like here's the terminals to connect the capacitors to. This one goes to, I guess, the ground, since it's also acting as a shield. And then here's the positive terminal. Yep, the positive terminal, which ripped off that pad on the circuit board. And this is just the way to make the LEDs have more contrast on the outside. Just using put a little filter on there, only let red light through. And looks like the fuse just, hey, that's pretty nice. Hey, that's a really cool thing how they did the fuse. So this is the fuse right here, just sticking out. And then one of the terminals, this is the ground. I got this. How does that work? Yeah, there's a little tab going right there. You've seen that other end of the fuse and this ground right here. So this top end just sticks right through to the other side. Not sure if there's a spring on the other side, or if it just... Oh yeah, there's a spring on the other side of this. It just hit that spring right there, and then you don't need a separate mounting panel right there for the fuse. It's all just in one piece. I guess it's this piece they just screwed right in. But it's a pretty compact way to do it. Let's have a nice front panel fuse right there, and also keep it compact at the same time. So here's the main circuit board of the thing. Looks like there's a nice little inductor right there. It's got the nice little windings on it. There's on the main system clock over here. Looks like they've put a little baud capacitor across this resistor right here, which we'll take a look at closer. There's also this, there's the 4 LED segments right there, which just display the capacitance value. Got a nice little range selector switch right here, which you can look in more detail too. And there's an old SO8 or DIP 8 package right there. And then there's the DC power jack right there, and then the on and off switch. It's just a close-up of the crystal right there. It's 4 megahertz. That's the main system clock. And they divide down into like 5 different clocks. The lowest one is 400 hertz, which I guess the lowest one would be less than 400 hertz, but it's just not the main circuit, it's a secondary circuit which handles the large capacitor values. So here's a close-up of this inductor. It's a transformer actually, but it's got the nice different multicolored windings on it. There's a number on it. Made in Mexico. There's 2 diodes right there. Got this. I think this is a clock divider chip based on the proximity. And it's a CMOS CD4511 BV. When did this thing come out? 1983? Maybe 8304? Is that it? Is that a date code right there? Look at this potentiometer. Oh, that's nice. It's a 0, I guess, on the 1 nanofarad range. It has a 0 trim potentiometer. So that's pretty nice. How much turns is that? Jeez. Oh, is that the end? There we go. Click. Maybe that's the end. Yeah, that must be the end. I can hear it. Must be about 50 turns or something on that. It's pretty good. Look how big it is. Jeez. Well, note some more, another trim. It's a trim resistor right there. Oh, those are stiff wires. Wow. I don't know what this. It's got some sort of number on it. Look at this. It's got like a paste or something on there. I'm not sure. That's weird. I wonder what that is. It's just discrete transistors right there. I like that silk screen on there. That's pretty nice to show which way they're going. There's this board down here, which houses the style switch right here to select the ranges. There you go. You can see the thing going around. Hit the different contacts on there. Might just throw a little bit of contact cleaner in there just to do that. Okay, I'll just spray a little bit on there. Maybe I'll do a little more. I kind of like how these things are numbered. It's R230 on that board, and then this is R100 over here. So this is board 100 right here. Board 100, and that's the board 200. And I think is there a secondary board under there? Oh no, that's just the batteries back there. So I guess there's just 2 boards in here. And this bottom board has other different components on it. So all these things have kind of strange numbers on there. And you can kind of see another chip just peeking out down there, another one right there. And must be the power supply section down there, which is probably the most likely thing that would go wrong with this capacitor unit, capacitor meter. I'm just going to use one of these DC to DC converters for this. It's just a simple voltage DC, it's a buck converter. So I'm just going to feed in about 9 volts and then reduce it down to about 6 volts, I think, since the charger is supposed to run on 6 volts. I guess I'll simulate the batteries being in, because I'll just gonna solder the leads right under there. Conveniently, there's a plus and minus symbol on the circuit board right there. You can see that's on the silk screen. Turn it on. All right, looks like we're getting something on there. It's a little bit hard to see, I guess. But it's 0.018, 0.019. So does this thing work at all? Hear this high-pitched whine coming out of it. It's probably one of the voltage or the frequency ranges that it's. So let's just. Yeah, I can definitely hear a high-pitched whine from one of the oscillator circuits. I think I'll make the quick LM317 circuit, just because it's probably lower noise in this DC to DC converter right now. I'm not sure that I think it works right now. It's one of those things where you just get it and it works. The seller says it's not working, but I think it works right now. So we'll just solder right on there. I'm not going to use this with batteries because I'm probably not going to have a time where I'm going to be like, hey, I wonder when I'm like walking around, hey, I wonder what this value of this capacitor is. So I'll just keep it stationary. Wow, that's pretty corroded. I'll just take a little bit of sandpaper here, so I'll just clean up a little bit. Hey, I got that contact cleaner too. Looks like I got finally some corrosion off of that terminal. That was pretty corroded bad from the battery. Looks like I got it off at least. So at least enough so the solder would stick onto it. Okay, I'm done soldering the circuit now. Looks like that. There's the LM307 right there. And I'm using a 560, or I'm using a 150 ohm equivalent resistance using 3 100 ohm resistors. One in series and 2 in parallel, and all that in series. So it's 150, and then I'm using a 560 ohm resistor for R2, and then the 150 for R1, and just the output filtering caps, just nice big ones just for extending the line around, and also have it connected to a 9-volt wall wart adapter. And then these 2 wires will just go out to the battery terminals just to power it, because and let's see if it fits into the unit. So that doesn't really fit too well. I could just cut out one of these pieces right here and do that. I'll just snip these linings out. There we go, that fits in there better now. Just cut a little bit away on the case. There we go. 100 microfarad right in the... Let's try 1,000. Oh, this thing wasn't on. Oh, there you go. Looks like that's working. 104.2 microfarads. 15 microfarads. It's pretty low. It's 100 microfarad range. Yeah, cool. So all it was just the corrosion on the battery terminals that prevented it from being turned on, I guess. It was on the ground of the negative terminal on the battery. It was all messed up. So maybe that's why it didn't turn on when the original owner tried to put batteries in it and didn't work. It was just too corroded. But now I've just got it so I don't need batteries anymore. I'll just run it right off the wall outlet. Apparently you can, oh yeah, there you go, you can zero the lowest range to get the most accurate reading. Let's zero it quick. And that's pretty good. Pretty stable. Oh, 0.01 microfarads now. Oh, there you go. It's on our lowest range. 1 nanofarad range. It's zeroed. But yeah, it seems like it's working now, so yep, it's a win. If you want to see my blog post on it, it's at weelectronics.net, and I'll post a link somewhere in here too, which I'll have pictures of it and a detailed post about it. This will just kind of getting it working.